Well, welcome to the next step on our Linux journey, and we're going to refresh and improve upon our knowledge of searching Linux files in the file structure. Then we will cover archiving and compression, two important topics that are done infrequently enough that most system administrators have to look up the related commands, and yet they're important enough that we need to walk through those operations of related commands, arguments, and options to prepare for our future Linux use. Now remember this cartoon shown here on the screen. Someone made it for a particular audience, and it resonates deeply with Linux and Unix system administrators for good reason. So yes, you should read these chapters of the training material, but you really need to conduct the exercises included in this presentation by yourself. Don't just watch me doing them, do them yourself to get the value out of it. Now we've been using Linux input and output channels, but we haven't really talked directly about it. The Linux command line redirects the information through specific standard channels. Now the standard input, which is also known as stdin or standard in, also channel 0 of the command, is considered to be the keyboard, and the standard output or standard out or channel 1 is usually considered the screen. We can change that though. There's another channel that is meant to redirect error output, also known as standard error, stderr, or channel 2 of a command or a program's error messages. So standard error is usually something sent to the screen or a log file, depending on what the program wants it to do. Now the input and or output can be redirected to something other than the default, including the error too, although the input redirect is not often used other than in pipes, and we'll talk about that later. However, standard out and standard error are routinely redirected. We've already used the greater than and the double greater than redirect operators, which we now know are redirecting standard out to either create or append to a file. Now we can add a 2 in front of that greater than or double greater than signs to have the standard error output sent to a file, and the and sign will send both the standard out and standard error to a file. Now the bottom 3, the less than, double less than, and then the greater than less than together, are used for redirecting standard in, and they're beyond the scope of a typical introduction to Linux class like we're doing right here, but they're included here so you know generally what they do. So let's go ahead and use the standard error and both redirects. Now first, make sure you're in your home directory, since you'll be creating a file that you want to find easily. So we're in home. Okay, great. Now let's go ahead and try to see the contents of the etc shadow file as a standard user. Now we know we can't, and typically when we try, we get something that says permission denied. So let's go ahead and do a tree, see what files we have there. Great. Now let's go ahead and cat etc shadow and see what it says when it throws the error on the screen. Okay, now let's send that error output using the 2 and the 2 greater than signs, and we're going to send it to the errorlog.txt. Yes, I don't have a file called errorlog.txt, and I'm using the append, but if one doesn't exist, it will create one for us. So cat etc shadow 2 greater than, and then error-log.txt. So this command sends the output to the error log, and we want to go ahead and cat the error log to see what's in there. And you will go ahead and see it looks exactly like what was shown previously on the screen. Now let's send both the standard out and standard error to a file called new file, and we will use the find command. And what we'll do is we will go ahead and look through the user directory for something that has the string admin. We're going to send the standard out and the error to a file called new file. So we use the end single caret because we're going to be creating this new file. We're going to call it new file. It's not a very useful command, but it serves our purpose. So let's go ahead and cat the file, and you will see there's a tremendous amount of output as the find user literally just calls everything that was in the user directory. And then at the very bottom, you'll see the error that find admin was not there. Don't worry, we'll get that one again. So now let's use the find command to search for all files and folders in the etc directory that include the calendar word in etc. So it's going to be etc calendar that we're going to be using for the find. And we're going to send that output to the new file command that we just created. So find etc calendar, we're going to go end, and then the double greater than signs to append to new file. And then we'll go ahead and view that so we can do a tail to see the last 10 lines. And there you notice there's the error from the previous command, find admin no such directory. And there happen to be 2 files or folders related to Etsy calendar in that directory. So let's move on to the next task. Actually, first, let's briefly discuss the cut command, which removes sections from each line of a file. Now, of course, you can use the man page for cut, but the 3 options shown here on the slide are most often used are TAC-F, TAC-C, and TAC-D. And we're going to use TAC-F and TAC-D on that new file that we just created to use an example. And hopefully after we do this example, it'll make more sense what benefit cut gives you. And there are some, and it's not something that you use every day, but it can be quite useful. Okay, well, maybe this could blow your mind a little bit, but I'll try to walk you through it. Let's look at just the first 30 lines of our new file and see all the stuff that it's in there. It starts with a root/user and it goes on with a whole bunch of other stuff, okay? So what we will do is use the cut command. We'll go cut TAC-F 3 for the third field, TAC-D for the delimiter, which is going to be the /. And then we're cutting from the new file and we're redirecting the output to a file called cut file. It won't mess with new file. It will just send whatever the output of the command cut is to the cut file. Okay, the output may confuse you, but you'll see that the output shows lib in the third field. Why? Well, in this particular case, we're looking at directories starting with root. Root is number 1. The delimiter is the /. That is the user. And then 3 would be lib in this particular case. So that's why it's 3. Well, you remember grep, right? Well, grep has numerous options which have not previously been discussed that can be used to tailor pattern searches as shown here on the slide. And we'll do more grep examples shortly, don't worry. Now, pipes, which we have covered also briefly before, redirects the standard out of one command and sends it as the standard in to another command. So the output of one command goes to the input of another one. And pipes can be chained as long as you need to get to your end result. And now is a good time to discuss the WC command, word count command, which is very useful for counting things like words, bytes, lines, characters, and even max line length. Now, we've used WC before just a little, and we'll do it again a couple of times, more in the examples that follow, just to get used to using that command. Now, the Etsy password file is a good one to practice searching with grep since we're familiar with it, or we need to be, and we can use some of those other commands we just learned, like cut and WC, with plenty of pipes. So let's first look at using the cut command, and we'll do a cut TAC-F, so we're looking for the field number 6, and then we want to use as a delimiter the colon, which we know delimits the different fields in the Etsy password file, and we will go /Etsy password. And what we'll do is we'll pipe that into the less command, which, as you know, brings up the output but doesn't load it all together, shows it part at a time. So go ahead and we'll go down to the end to see how much more we have left. And okay, great, there we go. Now, let's go ahead and do a cut, TAC-7, so the next field, and we'll grep for bash. And what is that going to do is it's going to tell us how many of those accounts are we going to have bin bash for, basically bash as the shell. And there's only 2. Okay, so that wasn't a useful command. Okay, fine, well, let's look at something different. Let's go ahead and go to the first field, which is the user accounts, and we'll grep for sys. So we're looking for accounts that have the words SYS in it, and we'll see how many total accounts have those letters SYS in it. And then what we'll do is we go ahead, hit enter. There's 6. Let's go ahead and look at those 6 to verify by getting rid of the pipe with the WC TAC-L. And yep, those are the 6 commands. Okay, great. Now let's go ahead and look at the current directories that we have in our folder. We'll look at the head, so the first 10, and we'll do a word count on those. So first 10 things in our directory. For word count, it says 85. Well, how do I know that's true? I guess we could go get rid of the WC tag W in head, and that, I guess that looks like 85. Okay, fine. Now let's go ahead and that new file command we just created, I want to see the last 15 files. So I'm going to use the tail command, and I'm going to do a character count. So WC tag C is 425 characters. If I go ahead and just look at that, I go, yeah, it looks like 425 characters. So there you go. That's a use of pipe, grep, tail, WC. Nicely done, I think. So earlier in the class, we discussed globbing, which was complicated enough. And now we will expand on that by noting that grep can use additional regular expressions to tailor its searching. Now, the new additions here are the dot for matching any single character, not to be confused with the question mark, which we will also use in our examples. There's the use of the thing that looks like a pipe between two strings, and we'll treat that as a logical OR, either the first or the second on either side of the pipe. Then there's the caret, upper caret, that looks for the start of a new line, and then there's the $sign, which is related to the end of a line. So yes, the caret outside of the square brackets is different than being inside as shown on the screen. And I know that's confusing. Yes. Well, we'll build some searches using the dictionary file located at user share hunspell, and hopefully we'll clarify most of the confusion around these regular expressions, what we've done previously. Now, to make our life a little easier, let's go ahead and cd into the user share hunspell directory. Now, if we want to see all the words in the file that contain the letters cat in order, we would use a pretty simple grep command. Where basically we would go grep, put the character, the string we want, which is cat, in quotes, and then the file we want to search in, which is the en_us.dictionary. Go ahead and hit enter. That's quite a bit. I don't know how many there are. Let's find out. Let's go ahead and pipe that into WC tag L just to see how many are in here. So you should get the same for your system too, 399. Okay, great. Now the next one requires us to find all the lines that do not contain something. So we're going to use the tag V option of grep, and that'll be good. And then we'll use the brackets around the letters of interest. So we'll go grep tech V in quotes, brackets A, B, C, D, E, F, G, close bracket and quotes, and then look in the en_us dictionary file. See what we get. Out of that list, my favorite word is yurt, by the way, and how many words are on that list? It is 2886. Very nice. Okay, next we want to look for lines that start with any three letters. So starts a line, we're going to have to use the caret to mark the start of the new line. And then for any three characters, the dots, 3 dots for 3 characters. Then the character string dig in quotes. That's kind of weird. So let's go ahead and grep in quotes, caret ... dig, end quote, the name of the file. And go ahead and hit enter, and look, cardigan. That's a very good one. I like cardigan. So that's how few matches there were in that particular case. Now, this next one looks at the end of the line. So we use the $sign. So grep, quotes, E $sign, so last letter E, in the US dictionary file. Let's go ahead and see what output we get for that. There's probably going to be a bunch. Yes, there are. How many is a bunch? Well, let's go ahead and do a word count tag L. See 939. Now for the next problem, we're going to have to use that logical OR. And we want to find words that have org, or, K, or tuna. So we're going to do grep. We're going to do quotation marks and then org, the pipe, K, the pipe, and then tuna. And of course, maybe type better than I am doing right now on the screen. So org, pipe, K, pipe, tuna. We'll search for a string that has any of those 3 in there in the US dictionary file. Now, go ahead and enter. You see nothing happened. Well, in this particular case, we have to use the tag capital E option to use the expanded regular expressions. There's the total list of Words, let's go ahead and do a word count. And we see there's 99. So let's go ahead and use the TAC-C for count also. Hit enter, we have 1. That's messed up, because I didn't get rid of the WCL. So let's go ahead and bring that command back up. Get rid of the WCL, and this will count 99. So that's the same as the WC TAC-L using the TAC-C. WC can still count other characters. Now, this last one is trickier. We want to start with 1 or no C. So we should use that question mark from our previous globbing experience. So we'll go ahead and grep CE, quotation marks, caret C from the beginning, quotation, question mark ATI, and then we're going to look in the US dictionary file. So grep TAC, C for count, E for expressions. Then we're going to do the quotation marks C, question mark ATI. And it says there's 3 there. Let's go ahead and get rid of the count just to see what those 3 are so you can see it on the screen. So there you go. That was a practice. That was some practice using our regular expressions in a dictionary file. You should be able to replicate these and get the same answers as me on your host system. Okay, now let's switch gears and look at archiving and compressing files. Now, archiving bundles files and folders into a single file, which is very useful for doing backups. If you're exporting data for some long-term retention, you want it all kept together. And when you're bundling source code comprised of multiple files and directories. Compression is often used with archiving to save disk space. And while some archiving tools compress files automatically, others do not, including tar, the program we will use the most in this class, or at least this presentation, for archiving. Now, there are 3 main common compression tools used in most Linux distros. They are bzip2, gzip, and xz. Now, which is best? Spoiler alert, there isn't a best, because every tool or algorithm has trade-offs, whether it's speed, RAM usage, CPU usage, faster, slower decompression than compression, and et cetera, et cetera, et cetera. Now, among the other trade-offs, gzip is the most widely used. Bzip has the best compromise between compression ratio and speed, and xz has the highest compression. Now, none of these compression tools provide archiving functionality, so you'll have to use another tool for that, like tar. Oh, and those pesky zip files that are sent by Windows users, or you have to send to Windows users, Linux can handle those too using the zip and unzip commands. Now, finally, the main compression tools listed here also have some ability to access compressed files without having to decompress the entire file using commands like zcat, zless, and zgrep if you're using gzip, and the other commands that are identified here on the slide if using bzip2 or xz. So let's go ahead and set the stage for using these compression tools and get ready for the archiving sections that will follow. Okay, first things first, we need to create the main LE3.1 directory we will use for the following exercises, and then the other directories and files we'll use to practice our compression and decompression. So first, let's go ahead and make dir LE3.1. I'm in my home directory, so I'm just going to go ahead and make the directory. Then I'm going to cd into my LE3.1 just to save me some typing. I'm going to make 2 subdirectories, make dir compression and archiving, 2 separate directories. Then I'm going to cd into the compression directory. Now, we need a big file. So let's take the standard out of catting the etc directory and everything that's in it, or a list of it, and send that to a file called a big file. And let's also send any errors to the dev null directory. Now, the dev null directory is a special file that's present in every single Linux system. However, unlike most other virtual files, instead of reading, it's used to write. Now, whatever you write to dev null will be discarded. And we will have some errors because we can't, for instance, cat etc shadow. So let's go ahead and type cat etc asterisk, and we're going to redirect that into a new file called the big file, and we're going to redirect the error to dev null. And then let's go ahead and ls and we see we have a big file. It's got 390K. Now, sorry for the jump. I made some typos in what followed, so I had to restart over. So now what we're going to do is we're going to copy this big file to big file 2. We're going to copy and make a copy of big file 3 and a big file 4. So 4 copies of big file, but named big file 234 and big file. Go ahead and ls tech lh that, and you'll see we have 4 390K files. Now let's just go ahead and run our compression commands of bzip2, gzip, and xz. So bzip2 big file 2, gzip big file 3, and xz big file 4. You should do these. Typing the commands instead of just looking at them will help you remember what the output is and how you type them when you get questions in the future. And after you've gone ahead and compressed, let's go ahead and ls tech lh and notice the different sizes which correspond to the amounts of compression related to the different algorithms. And notice that the original big file 2, 3, and 4 have gone away and they're replaced with their compressed version. Okay, now let's go ahead and decompress those files. So we're going to use bunzip2 instead of bzip2, and we have to use the file big file 2.bz2. And gzip uses gunzip, and xz compression uses unxz. And notice the file types of bz2 for bzip2, .gz for gzip, and .xz for xz compression. Those are important to remember. That's how you identify which compression algorithm was used for those particular files. Finally, go ahead and ls tech lh that, and then we're back to 4 390K files. Now let's go ahead and compress a file and use the zcat tool to read it. Now we just unzip some, or we just decompress some stuff. So let's go ahead and we'll copy etc host to the current directory, and go ahead and ls, make sure we still have the host file is right where we expected it. Then what we'll do is gzip hosts. We should end up with a host.gz file. Yep, and now let's zcat, well, first let's cat host.gz, see what we have when we look at this compressed file. It's a bunch of gibberish. So now we'll go ahead and zcat host.gz, and you'll be able to, if you can type better than I can, you'll see the actual contents of this compressed file. Well, there you go. That was a bunch of stuff to get us ready for the next phase. And just what is that next phase? Well, it's the fun part of the presentation and reminds us of that cartoon from the title slide. Now, true, you will have the tar man pages available to you in the future to help you figure out your archiving options, but you won't have a terminal with you when you take your certification exam. So we have to use and hopefully learn / memorize some important tar related commands, options, and arguments. First thing to note is, yes, there is a cptech-ar command that is copy with the archive and recursive options. That can be used to archive a directory and its files. However, this command is quite limited, and honestly, finding any details on how the archiving is completed is kind of difficult, so don't use it. Instead, we just use the tar command. Tar is the most common Linux archiving tool, and by default, it does not compress files, but it can call compression tools using command arguments like those listed on the screen. Now, tar is an interesting command in that it does not need the TAC in front of the options. By convention, try to use them. Try to use the TAC in front of the options, but it's not necessary, and you will often see tar commands without the TAC. So unfortunately, you should know the meaning of the 7 major tar options shown in the table on the left. The best way to learn them is to practice, and we will. Additionally, there are many arguments that go with those options. F is used a lot. You'll use it to add a list of file names to the archive in that same command line. Now, V is like verbose, but you really need to know the Z, J, and capital J arguments as they relate to archiving and compressing the archive file using the gzip, bzip2, and xz compression algorithms respectively, which we just went over. So there are a lot of options and arguments with tar. So we'll do a lot of exercises. First, let's cd into our LE 3.1 directory. Then we'll go ahead and do an ls just to see what's there. We have two folders. So let's ls into see what the contents are of those two folders. Okay, that's what we expected. There's nothing in archiving yet, but there will be. So what we're going to do is create an archive of that compression folder, putting it in the archiving directory, naming it 3.1.tar. So tar, C for create the archive file for the name that follows. The directory is going to be archiving 3.1.tar is the file. File name's compression. Now we ls. We see that we still have the archiving compression directories. Let's go ahead and look at what's in the compression directory. Nothing's changed. Let's go look at what's in the archiving directory. And well, now we have a new file called 3.1.tar. So, okay, great. Let's go ahead and cd into our archiving directory and let's look at that tar file contents. So we're going to type tar t f 3.1.tar. F is the file name. T is going to show us the what's in it, and you'll notice that what is in that tar file compression is the same as the file names that are in the real original compression folder. That's what the contents, that's the C word I can look for. So now let's go ahead and extract those files into the archiving directory. So we're going to tar x for extract f file name 3.1.tar. Notice I now have a compression folder in addition to the tar file. So let's go ahead and look at what's in that compression folder, and it's the exact same thing as in the real compression folder that we previously archived. Okay, great. Let's go ahead and get rid of that compression folder that's under archiving because we don't need it. ls it's gone. Now let's extract just the hosts.gzip file out of the 3.1 tar file and put it in the compression directory without any other files in the archive compression folder. So tar, X for extract, V for verbose, F for file, 3.1.tar, and then the compression /host.gz. You'll notice, even though we just deleted the compression folder, it is now back and the host.gz file is in it. And of course we can zcat that file if we wanted to see the contents of that zipped file, which we pulled out of the archive. And there you go. Okay, so we saw how tar works to create and extract archives. Now let's see how we can use tar's options and arguments to employ the compression algorithms we used earlier. Now the arguments of interest here are Z for gzip, that's the only easy one, sorry. J for bzip2, that's lowercase j for bzip2, capital J for XZ algorithm. First, let's go ahead and cd into our LE 3.1 compression folder, list the files, great. Now let's go ahead and compress big file to big file 3 into different zipped files. The C option is used to create an archive. Z uses gzip for compression. F calls out the files to be included in the archive. And we're going to call this first archive gzip.tar.gz. And it basically works the same way for the other compression algorithms. So tar is CZF, gzip.tar.gz, that's going to be the end file. And the files we're going to include in this compressed tarball file are big file 2, and big file 3. Now, I'm lazy, so I'm just going to go back and I'm going to change the commands for bzip2. So instead of Z, I'm going to use a lowercase j. I'm going to change bzip to the name of the compression algorithm we're using, bzip2, and the file is going to be a .bz2 file type. Go ahead and hit enter. Now, we are going to do the final one for XZ compression algorithm. So we use an uppercase J in our arguments. We are going to make it xz.tar.xz. And for the same 3 file names to be included in our archive compressed file. Go ahead and ls the current directory, and we see the 4 tarballs that we have, or 3 tarballs we have there actually, right? So let's go ahead and look at that with just for grepping tar. And the ones that we care about here are bzip2, gzip, and xz. Those are the tar files. These are tarballs because they are archived and compressed. And if we do an LSTech LH, you see the difference in the amount of compression. So there you go. That's it for this one. Okay, so we know how to archive files and to use tar to employ compression algorithms. But what if we archive some files and then we realize we forgot to add something to the archive? It happens. Now we can use the tar U option to add files to an uncompressed archive like following. So first, let's create a tar file called plain.tar and list the contents. First, make sure we're in our compression folder. See the contents. Now we're going to go tar cf plain.tar, and the file names are going to be big file 2, and big file 3. That is going to go ahead and create the plain.tar tar file. And then we can go ahead and look at the contents of that plain.tar tar file by doing a tar tf plain.tar, and that will list out the files that are in there, big file and big file 2 and 3. Okay, great. Now what we want to do is add big file 4. So we'll go tar uf plain.tar big file 4. Go ahead, hit enter, and then do the tar tf plain.tar to see if the contents are as we expected. And they are as we expected. Now it works. So I said you could use the U option for uncompressed files. What if we try it with a compressed tar ball? So let's go ahead and tar uzf, we're using a zip file, right? And gzip.tar.gz big file 4. Okay. So we're trying to send the big file 4 into the zip file, and a compressed file, it won't work. Now for giggles, let's go ahead and send that error output to our error log that we created earlier in this lesson. So we'll go back to the command and we'll say error output to double greater thans for append to the home directory error-log.txt, and then we'll go ahead and cat that directory, or actually that file, and see if our error showed up there. And yes, it did. Hey, you want some good news? It's the last slide. Maybe that's bad news. This is kind of fun. Anyway, let's deal with those pesky zip files that Windows users want or use. So let's go ahead and create a zip directory and some files to zip from the home directory. Going to make dir zip. Then go ahead and cd into that and make a directory called dir. I know, not very creative. Now, because I'm lazy at typing, I'm going to go cd into dir, and I'm going to touch file 1, file 2. So we've created a directory called zip. Underneath that, there's dir, and underneath it, there's 2 files called file 1 and file 2. So then let's create a zip file called zipfile.zip, and recursively add the current directory and subordinate files, and then destroy the directory folder using the zip command. So what are we going to do? We're going to go back to our zip folder and type zip tac-r zipfile.zip dir. So from the zip directory, we'll create that file. Now I'm just going to go ahead and get rid of the dir directory. So ls, go ahead and get rid of it. And so I'm going to rm.rf dir because I trust my zip file that much. Go ahead, ls. Okay, that directory's gone. So now what am I going to do? I'm going to unzip the zip file.zip and go ahead and do an ls. And you can see, or find to see what's in there, but also an ls easily shows you that dir is back, and what is in dir is file 1 and file 2. That's it. Okay, that's it for this presentation. Searching using grep and regular expressions can be confusing, but it gets easier with practice. And archiving and compression is not conceptually hard, but the infrequency of use makes it hard to remember sometimes. Hopefully you've completed the examples from this presentation, and then you will have a much better chance of diffusing that tar bomb when the time comes. Until next time, aloha.